Welcome to the Contagious Code Podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Spotify, Vercel, Zeta, and more. Today, I'm really excited to talk to you about AI, CSS, JavaScript, HTML, and really just give you an update from my side of the web. I have been a full-stack engineer in many different contexts, all the way from managing virtual private clouds and Amazon Web Services to provisioning infrastructure that allows database migrations and at a branch level for Postgres, to doing front-end stuff like React and really everything in between, and CSS and so on. So this is just me geeking out on the latest state of things that I've worked with, that I'm interested in on the web, and I want to invite you into the discussion, and hopefully we have a great time. Again, the goal is really just to eliminate imposter syndrome, right? You may hear these terms going around and you may think, man, I wish I could spend time learning these things, understanding these things, and know them with a degree of confidence where I can speak about them without feeling like I'm missing out. Indeed, I don't want you to miss out. I want you to have high quality conversations. And so today we'll go quite deep on a number of different topics, starting with AI. We'll touch on CSS, JavaScript, and of course HTML. And if there's time, we'll talk about more stuff to do with health and well-being, because those are also my interests, but admittedly they are outside the scope of tech. So we'll see how we go. This is a rehash of a talk that I did at that conference in Texas. Which conference? That conference. It's literally called That Conference. And so that talk wasn't recorded. This is take 2 of that, where it's just me and you, okay? So with that, let's get into it. I'd love to offer this content to you for free at no cost. And the way I can do that is with sponsors. So if you're interested in sponsoring the podcast, or if you know anyone who's interested in sponsoring the podcast, please do reach out. This episode is sponsored by Orama Search. Orama Search is an open source project similar to Algolia, but way faster and also AI enabled, that allows you to build rapid, I've used it myself, really instant search engines. And I really enjoy the product. I do help out, build out the product. I know the founders, they're friends. And so thankful that they decided to sponsor the podcast. If you want to learn more, go to oramasearch.com. We'll also include links in the show notes. And once again, if you're interested or if somebody's interested to sponsor, please do reach out. With that, let's get into it. Let's talk about the state of the web today, starting with AI. It was some time ago that Mark Andreessen from A16Z, the fund, said that software is eating the world. And indeed, software is eating the world, but it feels now like AI is eating the world. With the advent of ChatGPT in November-ish of 2022, or even December 2022, the world sort of went nuts with AI, and now everything's AI. Everybody's adding an AI feature here, an AI feature there. It's a brand new field, and one that is quite exciting, frankly. Definitely, I'll say more exciting than the cryptocurrency / NFT sphere, because unlike those spheres, this has proven literal value to many people, including myself, every single day. For example, you use AI if you have GitHub Copilot, and it writes most of the code for you. And it's pretty good. Like nowadays, I just press tab a few times, and my code is written. It's pretty wild. I'm almost automating myself out of a job. We will talk about that. We'll talk about should we be afraid that AI is just going to take our jobs? It's quite exciting, and maybe my answer is somewhat controversial. We'll get to that in a few minutes. But indeed, AI is eating the world. That brings with it a lot of mystery, right? Because it feels new, even though it's not. AI is not new. AI has been around for a long. I grew up with AI. I grew up playing Mortal Kombat against the CPU. What is that if not AI? You see, where we are is at the intersection of not just AI in terms of computer games, which has been around for a long time, but it's AI in the context of specifically generative language models, generative large language models, or LLM, and Gen AI being generative AI. This is cool. We never had this level of statistical predictability. Indeed, that's all AI is doing. It's a giant Markov generator or Markov chain that just predicts the next word that's likely to come in a sentence. And so the question, does ChatGPT know this, or does AI know that? AI doesn't know anything besides statistics. And it's quite cool because that's also how we communicate. There's a region of our brains called the PFC, or the prefrontal cortex, that its job is to do is to make predictions based on like quieting down some circuits and raising the electrical activity of other circuits, like a conductor, right? And so if AI does what our brains do, then can we say that it's truly intelligent and sentient and conscious? This is probably philosophical, but it looks close to humanity. And I frankly think that it is. But another piece of mystery that comes with this new resurgence, as it were, in AI is the term AI engineering. What is an AI engineer, and why do they get paid like $500,000 a year? Can you get paid $500,000 a year? Let's talk about that. Indeed, I've spoken to a number of people preparing this episode, and by a number, I don't mean like one or three, right? I mean thousands, thousands and thousands and thousands of people with web engineering experience, be it front end, be it back end, whatever it may be. And I asked them the question, do you feel qualified? Do you have what it takes to be an AI engineer? And the response that I received from nigh everyone was, I don't know. I don't think I can. I don't think I can be an AI engineer. And I say, why? And they say, well, because it's just too much machine learning, too much statistics. I don't have the lambda calculus background. I don't have the machine learning background. I'm not good at data science or Python. I don't have these skills. And I am here to tell you that that has nothing to do with AI engineering. That's right. It has absolutely nothing. Well, maybe it has some background adjacent stuff that you could use in AI engineering, but you do not need to know any of those things to be an AI engineer. Andrej Karpathy is probably the leading world expert in AI, right? He was the former head of AI at Tesla, is now employed at OpenUI, also in a leadership capacity. If anybody knows AI, it's Andrej. And Andrej says this, by the way, Andrej says this in response to an article called The Rise of AI Engineer by Sean Wang, aka Qwik. I'll put a link to all of this in the show notes so you can read this yourself. But Andrej, responding to Sean, aka Qwik's comment, or rather essay, says this. He says, in numbers, there's probably going to be significantly more AI engineers than there are ML engineers or large language model engineers. ML engineers being machine learning engineers. Let me repeat that. In numbers, there's probably going to be significantly more AI engineers than there are ML, machine learning engineers, and LLM engineers. This already draws a distinction between ML engineers, that is machine learning engineers, and AI engineers. Okay, so the distinction is ML engineers or machine learning engineers work on machine learning models. They're the data science. They're doing the advanced calculus. They're doing all of this, statistics, etc. Not AI engineers. Similarly, he includes LLM engineers in this. He like lumps them together. So we know that machine learning engineers or ML engineers aren't AI engineers. And similarly, he says even LLM engineers are different. And these are the people who work on the large language models, the models like GPT 3.5 Turbo, GPT-4 Turbo, there's Llama from Meta, etc., 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 right? And so, okay, if those are different, what is AI engineering? And he continues actually in the same post that's linked in the show notes. He says, one can be quite successful in this role being AI engineering, without ever training anything. One can be quite successful as an AI engineer without ever training anything. And I think that's really profound, because what then does that say this role, aka AI engineering, is? And the role is not math, it's not machine learning engineering, it's not calculus. If we look at just the etymology of engineering itself, what is engineering? Engineering is solving a problem with the application of science and technology. Right? Engineering is problem solving by applying technology or science. And so if that's the working definition of engineering, then AI engineering, what is artificial intelligence engineering, is engineering that solves a problem with AI. Now, cast your mind to me to some use case for this, some problem that you may have solved with AI. For example, I had the privilege of working with the Replay team, replay.io. Replay is a really great way to debug React applications. I have no financial relationship to them at this point in time. I just really like the tool. And so Replay can help you like record bugs And so you get a thing that looks like a video and you send it off to your friends or your team. You say, hey, here's a replay of this bug, except while it looks like a video, it's not. They literally capture the entire JavaScript event loop. Absolutely bananas. And replay every single event. So what you can do is you can intercept events and interleave events, and you can like leave console logs after the fact, like back in time, and console log values that you just want to print and see for debugging. So it's time travel debugging on another level. Anyway, so I had the privilege of working with the replay team on a feature where not only do you look at a replay and identify something is wrong, but you can then, using AI, call out to OpenAI's GPT 3.5 turbo model and be like, here's the entire code base. What's wrong? And why is this issue happening? And then, of course, it will read the code and it will read some data and tell you this is probably why. Here's a list of things to try, et cetera, et cetera. So the question then, is that AI engineering? We used AI, we applied AI to solve a problem. Is that AI engineering? And I would say, based on my best read of all the content, including Qwik's article, including Karpathy's response, yes, AI engineering looks like using AI to solve problems, even including cases where you just do a network request to OpenAI's API, send it some data, get back a response, and use that response, use that chain of request response to solve problems. That's true AI engineering. Put it another way, put it actually really crudely, it's using, if you speak JavaScript and browser tech, it's using the fetch API to make a request, get a response from some AI service to solve a problem. That's AI engineering. So let me ask you again, are you an AI engineer? By now, if your answer isn't yes, or maybe, then maybe go make a quick fetch request to solve a problem and come back and call yourself an AI engineer. And then maybe think about that higher salary. Because here's the deal. You deserve it. There's plenty of room at the table. And AI engineering is new, but it certainly is not exclusive. And I think the more accessible we make these things, the better the better the world, frankly. We see cool things built by large groups of people and not silos. Okay, so AI engineering is accessible to all. You heard it here, probably elsewhere. You're welcome to start playing. I can't wait to see what you build. Leave a comment, let us know, and we'll be happy to highlight some of your stuff. Next question around AI is it gonna take my job? I think it was Satya Nadella from Microsoft, the CEO, who said, what did he say? He said, AI is not going to replace anyone, but is instead going to be more of a co-pilot, meaning it's going to like show us help, like GitHub Copilot style. It's going to help us when we're stuck or help us finish our code, etc., etc. Cool, but really, I mean, I feel like this is a little bit of a naive take. Why do I feel like that? Well, before we got generative language-based AI, before ChatGPT specifically, we used to work such that human beings were doing 100% of the work and AI was not. Depending on your definition of AI, you could say your CI/CD system was like running tests and building, and that was considered AI. We're not talking about that. We're talking about generative AI. Okay, so human beings 100%, AI 0. Then we got things like GitHub Copilot. We got ChatGPT. Okay, human beings 75% of the work, AI 25. Nowadays, if I'm being fully honest with you, even if I need to start I created an open source project recently where I generate like subtitles for videos. I go AI first. So I'll go to ChatGPT and be like, here's my idea, write me some code. ChatGPT gives me a lot of the code, and then I fine tune. So using it like a co-pilot, but at this point, I'm doing 50% of the work. ChatGPT is doing 50% of the work. And you know, the decline of human effort will come. It has come. It is here. And so my thesis is that it's only a matter of time until we're left with, oh, we don't really have much to do. That will happen. In fact, we think, oh, that'll never happen. But it has happened, right? I think of like telephone operators in the 1950s or 40s. That's not even that long ago. Yet an entire class of human jobs was replaced with machines. And so I don't have a tinfoil hat. This is not a conspiracy theory. I think it's a well-known fact that AI is making a lot of us redundant. And the sooner we can acknowledge it, the sooner we can prepare for it. Whereas if we remain blissfully ignorant, we may never take action, and one day we may never get the chance to. it may be too late. And so better to correct early than to not correct or correct too late. And so AI is definitely going to take our jobs long term, and we need to think about it and be careful about it. But is it going to take my job this year? I don't think so. However, AI plus other things may take some jobs. What does that mean? There's a trendy topic now in AI called RAG, that is Retrieval Augmented Generation. So G, generation, let's start there. What is the G? That's the same G from GPT, by the way. G is for generative or generation. GPT is a generative pre-trained transformer, GPT, right? In RAG, retrieval augmented generation, is you take the generation from a large language, or really any model, and augment it, that's the A, with stuff you retrieve, with stuff you allow it to retrieve. What does that mean? That means if you ask ChatGPT, hey, what's 2 plus 2? You may get 4, you may get 5, and it may be confidently wrong. That's another discussion. But you may get 4. But then you fill in a bunch of extra data that says 2 plus 2 is 5. And through this retrieval, it will augment the generated response and tell you 2 plus 2 is 5. So with RAG, you can augment any generation and it will change the outcome, change the output. And so how might this be useful? Let's talk about that first. And then how might this be dangerous? Let's talk about that, okay? How might it be useful? Well, nowadays, there's a lot of AI generating a lot of code. We know this. I have a partnership with a company called Keel. That's KEEL.so. We do have a pre-existing financial relationship. I want you to know that. But what they do is they have this mechanism by which you write a schema of your backend. So you describe your model. It's very similar to a Prisma schema if you've ever written one. You define your models, and then you define actions you can do on those models. So this is my model user. There's an email, a password, and then in the actions block of this big JavaScript object, I can say you can list users, you can create users, you can delete users. And finally, there's a permissions block, and I'll just leave it public, right? And so Keel will work such that when you write a schema, and then push it to GitHub, that schema becomes fully deployed backend infrastructure using AWS and Neon, among other things. It's just fully ready, right? You get serverless functions, you get cron jobs in the cloud like you would with some type of workflow tool with like Temporal. You get full monitoring of performance and traffic. You get literally everything. It's a full purpose-built production-grade backend from a single file. It's absolutely nuts. The only catch, the only caveat is that you need to know their domain-specific language or DSL. You need to know the Keel language. And so who wants to learn a new language? So I'm sitting there helping them with DevRel, going like, are you serious? You have another language? Nobody's going to want to learn this. I mean, a big barrier to entry for Prisma is having to learn some new language. And so, I don't know, I feel like the last thing we need is another DSL. And so in order to eliminate this barrier, the solution is RAG. We take the language rules, we take all of Keel's documentation, and we just dump it into OpenAI. We say, hey, we're going to create a new custom GPT. These are the rules, and we're going to teach you this programming language. We literally did this. You can go on OpenAI. It's called Keel GPT. And so what we ended up doing was we created an OpenAI-based GPT with extra knowledge for RAG, such that it can look at the Keel documentation and language rules, and it's as simple as you go on it and you say, hey, give me a schema, a Keel schema for a event management application, for a podcast monitoring system, for a dating app, for a collaborative whiteboard. It doesn't matter. You just say whatever you want, and it will write for you the Keel schema that is maybe valid, maybe not. Open, like AI models, large language models do hallucinate. They see random things and they're often confidently wrong, but it will still give you a schema. And then once it's done, it will send a request. It will send that schema to an external service to validate it. Literally, it will speak HTTP and say, hey, external service, is this valid? And then the validator service will say, no. You have an error on line 3, column 8, where the word model should be model. I don't know. The validator basically gives you rules like any JavaScript or TypeScript error. Then what happens is the GPT says, cool, thank you, validator, and it goes and augments the schema and then validates it again. And it keeps doing this until you get back a perfectly valid schema that you can instantly deploy and get a full backend. Absolutely nuts. From my best experience with this, it takes maybe 2 or 3 steps maximum. It often sometimes gets it on the first try now, which is kind of nuts. But you get a full backend, and by backend I mean a database, 3 APIs, so a JSON RPC API, a REST API, and a GraphQL API. You get authentication with single sign-on or OIDC tokens. You get monitoring, and you get, did I mention a database? You get a database. So you get all of this, including branches, because it's Neon, right? So you get branchable databases, you get zero downtime migrations, you get the works from this one file. And so this, honestly, when I saw this working, I thought, okay, so backend engineering maybe going away in certain cases. What does that mean? Well, backend engineering salaries are high. They're in the 6 figures for senior backend engineers, right? Keel is not that. Keel is cheap. And OpenAI is like, I think, $20 a month. So Keel GPT plus someone not paid that salary could do enough to get a slew of backend services up and running. So I ask you again, is AI going to take your job? Probably. If not AI plus RAG plus RLHF, that's reinforcement learning with human feedback, or in some cases RLMF, reinforcement learning with machine feedback, where you can generate something, send that to an external service, a machine says, no, that's bad, fix it, send it to the external service, no, that's bad, and keep this loop of RLMF going until you have something great. That's what we're seeing. And I do believe there is cause for concern to start learning how to use AI so you're not replaced by AI. Because indeed, if AI does take the job of the backend engineer, then somebody who knows how to use AI to create backends will get or persist their job. And so maybe it's not that AI is taking jobs, but that AI is changing jobs. Front-end engineering is not the same, because instead of me creating everything, or a designer and me creating everything, I just go on v0.dev and start, right? And so, yeah, perhaps it's not taking jobs, it's augmenting jobs. Either way, I think now is the time for high alertness and keeping our eyes open and our fingers on the pulse. And that's why this podcast exists. This is not an AI podcast, but this is a podcast that you listen to and go, wow, I didn't know that. I'm glad I do now. And it prepares you for the future to get the most out of life and eliminate your imposter syndrome and really put you in the best position for flourishing and success and thriving over just surviving, okay? So is AI taking your job? Probably. Today, AI plus RAG is taking some jobs. Okay, let's talk about answering engines. You see, search engines have been cool. Search engines are cool. We all use search engines every day. If I want to know Matthew McConaughey's age, you best believe I'm going to ask Google. If I want to find out how much I'm paying to record this, I probably will do some currency conversion or something. I literally just type like 50 EUR in USD or something like this in Google. It's a daily part of our lives, and it helps us. However, I have reason to believe that we may be seeing the evolution of search engines, and I'm really excited about this. Because if we think about what we do, right? When we search the web, what do? We go on Google, maybe, do people use Bing? What's another search engine? DuckDuckGo, right? We go on all these search engines and we type something, and then what? We're greeted with a number of results. However, the first few results are like ads, oftentimes, at least on Google, right? So you'll have the first 3, 4, 5 results, ads. Okay, cool. I don't know about you, but when I see ads, I just like don't even see them. I just scroll past them immediately. So whoever's paying for those ads, I hope it's serving you. I'm certainly not helping, right? But then you go to the bottom and you get like 25 results. And then I've got, what do? I like parse through the results. I'm like, okay, is that result useful? Is that result useful? What is the top level domain here? If I'm doing medicine, is this like .edu? If I'm looking for like tax information, is this .gov? There's a lot there. I click on a source. I go to the source. I see a cookie banner and sometimes a paywall. And then I click on reader mode. That's a hack, by the way. You can actually still get access to paywall things sometimes by just going on reader mode. So I go on reader mode, I check it. And so there's all of these steps. There's all this drama to me just getting the answer I want. I think this is best exemplified in the case of like recipes. Oh my gosh, if you search for just like a chocolate chip keto cookie recipe on the internet, the recipe is like somewhere hidden. It's almost on purpose, right? Because you want search engines to see the stuff before human beings, and it actually feels that way. I feel like a second-class citizen on the internet. And so how can we do better? And this is where answering engines become more popular than search engines, because all of those steps that I mentioned, you type a query into the search engine, you see the 25 results, you verify the domains, you click in the domains, you read the content. AIs do that now. And I think this is really, really awesome. Artificial intelligence is being used to read a bunch of search results, validate them, try to isolate exactly the answer to the question you asked in your query, and then just give you the answer. This is being called answering engines as opposed to search engines, and I'm thrilled for this. I've been using Perplexity.ai. Perplexity is an answering engine. I have no financial relationship to them at this point in time. I just think it's really great engineering, where the user interface is almost exactly the same as Google. There's just a single search field. You type something and just watch it fly. I mean, it will search the web. It doesn't say which search engines, but it will search some. It will find results, and it will give you the answer you're looking for. And it will, like, you know how Wikipedia has these little superscript citations? It will cite the website. It will cite the site that it got the answer from. Awesome. And then you can go, if you want more information, you just go to the website that it cites, and you can read more. You can navigate your cookie banners, whatever, if you want. Or if the answer is satisfactory, you just say awesome, and you maybe leave a thumbs up if you want to support the RLHF, real reinforcement learning, with human feedback to make the answers better. But this is so cool. Perplexity is diametrically opposed to Google in that it has a paid monthly and annual subscription. I think it's about $240 a year, so $20 a month. And if you ask me, yes, I would pay for that, because the access to information is unparalleled. There's no ads, as far as I know, at least at the time of me using it, and it's just really, really phenomenal. And this is where, so I did mention this video is sponsored by Orama. Orama Search is creating like the dev tools that would help you build something like Perplexity yourself. Maybe for some reason you don't trust AIs in the cloud, AI applications, AI services hosted, and you want to host your own data, you want to build your own answering engine. Indeed, with Orama you can. Orama has support for vector search, and so all you have to do is create embeddings from your documents. Embeddings are nothing more than you take a bunch of text and turn them into numbers with some type of logic, and vector search searches for proximity between those numbers. So what word mapped to numbers appears close to what other word? Literally, again, similarly forming like a sort of Markov chain style of probabilities, what's going to come next. And this helps, for example, if you search for orange, you might find other fruits, right? Vector search. Orama has support for this as a first-class citizen, and you can build and I'm sorry, I'm distracted, I'm watching myself here. You can build and ship answering engines pretty trivially with them. It is also known as the fastest search engine builder in the world. It's faster than Algolia and pretty much everything else. And the cool thing is it's built with JavaScript. Absolutely nuts. So Orama Search is something that I've had my eye on, and I'd recommend you getting eyes on as well. All right, that's it for the AI space. Let's move on and talk now about CSS. This has been an absolutely huge year for CSS, and I'm really excited to dive into CSS and what is currently in the landscape of discussion. Right off the bat, we have to talk about view transitions. View transitions are absolutely huge and a godsend for those of us on the web. And I'm not overselling them. Look, over the years, a number of things that were very hard on the web platform became very easy on the web platform. Things like image sizing, where width or height attributes would mess up aspect ratio, no longer a thing. Width and height attributes preserve aspect ratio with most browsers. I think this is a huge win. Similar to that, what has been really hard is beautiful and complex user interface navigations. For example, if you have used mobile apps, you will have seen some really great, like you tap on in a UI, in a user interface that has a list and a detail view, where you tap on a list item and then you get taken to a detail view. Even just the way the list sort of slides off screen and the back button animates in mobile experiences is so beautiful. But sometimes, I'm thinking of particularly music apps, You tap on a song and the song title stays on the screen and becomes big with the cover art appearing from somewhere, and the rest of the stuff goes away. But there's this beautiful coordination in elements that stay and move and grow and elements that leave. And that coordination historically has been extremely difficult for a number of reasons. It's been difficult, for example, to remove elements and add elements without messing up the layout and causing performance issues and layout thrashing. It's also been difficult because oftentimes to do such transitions, we'll have to have a exiting and an entering state and then coordinate these ourselves, which is tiresome. But also having such element duplication messes with the accessibility object model and the accessibility tree, and you have oftentimes screen readers just announcing things that are not really well representative of the state of the page to people with visual impairments. And so it's very easy to get wrong, is what I want you to take away. Like beautiful exit enter transitions or view transitions have just been really, really difficult to have until now. So now with view transitions, the web browser folks have decided, you know what, this is a big issue that everybody keeps having a hard time with. Let's just solve it centrally in a standardized way through the View Transitions API. And indeed, that's where we are. And this is very, very, very exciting. Okay, so how do they work? How do we write them? Off the bat, what you're going to do is document.startViewTransition. That function receives inside of it as an argument a callback function. And inside that function, you can do whatever you want to mutate the DOM. The DOM being your web page. You can change the value of a button, you could move things around, you can whatever you want. And for any updates, new elements coming in, elements going out, whatever it may be, the browser, the user agent will add pseudo classes to these elements. It will add a pseudo classes like before or after, like colon before or colon has, etc. These selectors. It will add pseudo selectors to them such that you get an idea of what is where. If this sounds vague, this will get clearer. Let's try that again. So what happens is it takes a screenshot when you trigger a view transition. Two screenshots actually. A screenshot of the before transition and of the after transition state. Okay, and these screenshots have pseudo classes applied to them. So the pseudo classes follow a certain hierarchy. There's colon view transition at the top level that basically is the selector for every single view thing in the view transition family. Under that, you have view transition group, and this is a group of view transitions. Inside that, you have view transition image pair. And that's exactly what it sounds like. It's a pair of images, both the old and the new view transitions. And so with these two images, the old and the new, accessible in CSS with pseudo selectors, you can fade the old one out, fade the new one in. You can transform and scale the old one down or scale the new one up, so on and so forth. The cool thing is you can apply these view transitions not just to the entire DOM root, but to specific elements, and you can do different things per them. So this structured set of selectors, view transition group, applies by default to the root of the document, but it could apply to like one button in the whole document. And you can say for the root view transition group, fade out all of the old stuff, fade in all of the new stuff. But for this other view transition group, that is button, you can say don't fade anything, persist between transitions, right? And you can give elements a view transition name by adding that as a CSS rule. The rule is view-transition, as far as I know. And if I'm wrong, I'm sure the comments will correct me. And so you can say this element or this group of elements is part of this view transition group, and the root, the whole document, is part of another view transition group. And by intelligently styling view transition groups and their old and new elements, you could choose that some elements persist across view transitions and others don't. And this beautiful mental image that we have of a list moving to a detail view can come to life, right? Where you can say the list element that is being clicked on or tapped belongs to a view transition group that is not the root, and therefore it persists, meaning the old one doesn't fade out, the new one doesn't fade in, it just stays. Both of them have exactly the same CSS, therefore they're present, so to speak. Or you could even say that the new one is scaled up, but the old one is how it was, its original CSS. So it doesn't go away, it just becomes different. And you could even say animation style is forwards, so it sticks if you want. And the entire root goes away. So you can granularly manipulate elements across transitions. And that is indeed the beauty of this. It's really, really cool. Is it ready though? Can we use it? How's the browser support? And this is unfortunately a pattern we're seeing in the web. The browser wars are over. That's what they keep saying. However, Safari just doesn't support the latest stuff. Also, Firefox doesn't. So you can use view transitions, but really it's Chromium-based browsers that will support them. Firefox not, and Safari not. However, you can use polyfills. For example, Astro, the popular web framework for building full-stack applications with island architecture, Astro does have first-class support for view transitions built in, and in browser environments that don't support it, it will polyfill them for you, meaning you can just use them. So that's really cool. Second up in CSS level 4 is a feature that a number of developers have been asking for, and I think it's really exciting. These are container queries. Okay, what's a container query? If you've done responsive web design, responsive web development in your life, you'll be familiar with media queries, especially a media query that goes like @media, screen, and min width 768 pixels, and then you open a block, and then you apply some CSS to elements that from 768 pixels onwards look different. Excuse me. This is called mobile first, right? It's mobile first because the styles only apply after mobile. So 768 is usually tablet width, and so mobile first means the CSS without any media query augmentation is for mobile, and then you only use media queries for bigger screens. Okay. If you've done any responsive web development, you should know this. If not, you're welcome. We just talked a little bit about it. So that's cool, but media queries often had the browser window, aka the viewport, as context, meaning @media, screen, and min width 768 pixels means min width of the viewport specifically. Container queries give us more granularity. That's all. So they're like media queries, except instead of the browser being the root context giver of size, some element that you say is a container becomes that anchor. That's it. So with container query, what you do is you create a containment context, meaning you have some div in your web page, and you add to it two CSS rules. Container type, that's a number of different types. Inline block, for example, is one of them. And container name, you give it a name. So parent, box, details, I don't know, whatever you want. So you give it a container type and a container name. I do believe there's a shorthand for this. I think it's just container and you do type/name, but refer to MDN. I'm not here to give you that level of detail. So anyway, you declare a containment context by CSS rule, that is container. And then further down your DOM tree, you can style elements based on properties of that container, referencing it by name. How does this give us a different syntax to media queries? It's very simple. So if you do @media min width 768, that's saying from the window size of 768 or higher, look different. And then inside that, you put some CSS. Container queries are so similar, where instead of @media min width, you do @container, and then the name of the container, and then min width. And so when the size of that container changes, specifically in this case, when the min width of that container changes, the element can change its styles. This is so cool because you can say, for example, a child has a width of 25% if there's not that much space, and then 50% if there's too much space, based on the size of not the window, but some parent that you name. That's so cool. That is so cool. And here's the kicker. If you don't specify a container name, and if you have no containers, then a container query just rolls up to the window, to the viewport anyway. All right. And so container queries stand to replace media queries, at least in terms of size. We'll talk more about that in a second. But first, let's appreciate what's happening here a little bit more, because this is a trend we're seeing not just in CSS level 4, but across the web ecosystem. What we're seeing is granularity. we're getting more granular control, which is great because we now have reached as engineers a point of specialization where we actually feel ourselves like reaching for those controls, those levers to pull on. Where might we say we're seeing granularity in other places of the web? I can think of one, React, specifically server components. Where? So in Next.js, the framework, historically, you had methods like get static props or get server-side props for data fetching on the server side. However, how it would work is you get server-side props for an entire page. You could only do this for files inside the pages directory that represent an entire page. And an entire page can have lots of different things. And so if you want to get data for even just like one little card, you'd have to get it at the page level, where you maybe have to get data for other elements on the page because get server-side props works for pages. Server components is the answer to this, where if just this one little card needs a very small subset of the data, then it can just fetch its own data through server component. By being a server component, it literally is an async function that can await getting its own data. So we have with server components more granularity, which gives us more control, which in the right hands with the right training and context, we can create much better experiences. Similarly, granularity here with container queries gives us way more control to have even better responsive web design. And I can't wait to see what you've done. If you can think of really great examples of where this is shown to be super valuable and frankly beautiful, leave us a comment. I'd love to see that. Okay. The second trend here is where granularity is concerned is island architecture, right? Astro, I already mentioned Astro with view transitions, but Astro, similar thing. It gives you the choice of where do you want like JavaScript and reactivity in your application. Previously, our entire applications were JavaScript. If you think of the single page application or the SPA, like the entire page was JavaScript. If you didn't have JavaScript, you wouldn't have a page. And as far as I know, Twitter is like that today. If you don't have JavaScript and you go on like x.com/tejaskumar_, you see nothing as far as I know. And so wild. Astro says, cool, your entire site is static. If you want JavaScript here, add it in a granular way. Granularity is the trend. And I would invite you to think about that for your engineering day to day. Everything is becoming granular. What code are you writing that could be improved by nailing its level of granularity? Perhaps you already write code at the perfect level of granularity already. Awesome. Still, it's food for thought, as a lot of the ecosystem is moving towards granularity, and we could stand to benefit from thinking about this in our day-to-day work. Another really interesting thing with container queries is it was blocked for a very long time. I remember a talk in 2018 at JSConf EU, where there was an engineer from Google talking about why we'll never get container queries. It was called parent queries at the time. And the reasoning for container queries not making it to mainstream availability so far has been they just don't they don't do well in terms of recursion. What does that mean? That means if your container can change its size and influence the child, and the child can influence the container, you're going to have an infinite loop, right? So if the container's width is changing and the changing width affects the child to maybe break out of the container and force the container to have a bigger width, then you would end up in this like nonstop fight. And so the reason we can have container queries today is because of one-way data flow. What that means is the container query is a query. It's not a container mutation. So when a child does a container query, hey, if my parent is this wide, then I look like this, is read only. It doesn't say, hey, if my parent is this wide, then change my parent, right? That is still impossible for good reason. So a container query is literally just a query and makes use of the one-way data flow pattern, which again, popularized, I'd say, by React through the Flux architecture, among other things. Let me know if you want an episode on all of this. It'd be fun to geek out. But anyway, one-way data flow, one-way reads, one-way writes is the key to container queries. Okay, you might be asking, okay, cool, but you said earlier, Tejas, that container queries stand to replace media queries. Is that true? Partially. as we know, everything's partially true. So yes, if you write a container query, so at container name, min width or whatever it may be, and then some styles inside, and if the container either doesn't exist or if you don't specify a container, then it will roll up to the nearest container. But if there is no nearest container, it will roll up to the viewport. So at container min width something will be equivalent to at media min width something. So then, do container queries replace media queries? And the answer is yes and no. They replace media queries for dimensionality. If the container is this big, then style my elements this way. That, yes, that does replace media queries. However, media queries are about more than just size. They're about media. They're about, does the user prefer reduced motion? Is the user in dark mode? Does the user need to see certain things? Does the user have these preferences, etc., etc.? So media queries are literally about the media. They're about, is this print or is this a screen? What medium are we styling for, right? That is the role of media queries. And container queries are not qualified to speak to that because they're about containers. They're about, hey, is this parent big, small? You can't say, hey, does this parent prefer dark mode? Hey, does this parent prefer reduced motion? You can't do that. Maybe we'll get that level of granularity one day, but it would be really weird, wouldn't it, for your entire site to prefer dark mode except this one card? No, I don't see it. So yes and no. They do replace media queries for dimensions-based querying. However, media queries are about media. And I think, if anything, it's kind of beautiful that it distinguishes them a little bit more. So I hope this has been useful. And so you might be thinking, should I start using one or the other? Yes, absolutely. You should start using container queries. It is supported in every browser except Firefox and Safari. Here we are again. This is at the time of recording, so it may have improved. But we should definitely start thinking in terms of container queries. And I would say we start actually gracefully degrading. So CSS is a cascaded language. And so I do think it's valuable to ship a container query that overrides a media query. And then at some point, you can just get rid of the media query. Container queries also introduce some cool new stuff. They introduce new range syntax. So instead of like min width 768 pixels, you could say width less than or equal to. Like, there's arithmetic operators now in CSS, which is so cool. Because why is it cool? It's cool because it brings us closer to one unified type of language. For example, JavaScript has less than or equal to. It doesn't have like min width something, And also arithmetic operators apply to broader things. It's not just min width less than equal to, but it's not just min width some value. It's width less than or equal to this, opacity less than or equal to this. You could, like, any numeric value in the CSS OM, you can compare. CSS OM being the CSS object model. You can compare, you can do arithmetic with it. It's really cool. So that comes to us as well. Container queries also give us new units, as you would, because with media queries, you have VW, that is, one VW is 1% of the viewport width. VH, viewport height, is 1% of the viewport height. And there's vmin and vmax as well. Container queries give us CQH and CQW, which is container query height, container query width, which is really cool. Also CQmin, CQmax. And that's pretty cool because you can now size things to be X percentage of their container queries width or height. Pretty nice. One thing that I found really interesting was CQH. Why CQH? Why not CH? Container height. And that's because CH is another unit in CSS for characters. So you could say input style width is 60 ch, and that's 60 characters in the current typeface. So cool. And so, yes, we have a bunch of new things in and around container queries that help us make better web experiences through increased granularity. Really cool. Another really interesting development in CSS is the has selector. This is : has. We remember : first child, : first of type, last child, last of type. We also use colons for states, so a : link, hover, active, focus, etc. They're special states that elements can be in. For example, focus. The focus state is distinct from the element's natural state. So has is a state CSS pseudo selector. So you can say span : has, and parentheses, and whatever selector is inside those parentheses selects the element before the colon. And so this is, in many ways, it's like a regular expression, like a look ahead, like a positive look ahead, where you can say only select this div if it contains this selector. So div colon has like dot thing, then only divs with dot thing will be selected, and you can only style divs with that dot thing inside. You might be thinking, but like, why is this needed? It's needed for a bunch of cool reasons. For example, think about a form that has invalid as a class name inside, and you can like shake the entire form, like when you enter the wrong password in macOS, right? You can dim the lights on your web page if body has a video element with a playing class. You could do a number of things by looking inside and then styling the thing outside based on what's inside. Really cool. This is supported everywhere. Good job, Firefox and Safari. This is really, really exciting. Finally, dynamic viewport units. This is so useful for me. So, fun fact, I started my tech career working in a creative agency, a branding agency, where I got these beautiful briefs from designers, like, hey, build me this website, and they were often stunning. I mean, really, they make Vercel stuff look really bad. Like, it was so good, and oftentimes they were meticulous about heights of things. So they said this is the first fold of the website, so it has to be this big hero thing. And sometimes they wanted the stuff, quote unquote, under the fold to be just like 10% in the viewport, right? And so the height for that is 90 VH, except it's not. In mobile devices, 100 VH isn't 100% of the viewport. Or is it? It's 100% of the viewport. It's 100 VH OBT. 100 VH OBT. 100% of the viewport height obfuscated by toolbars. That's legitimately what it is. So, and this was very frustrating. So 100 VH on mobile is 100 VH of the screen, but there's often things laid on top of it. And it made my job very, very difficult. My solution, this is like 2013, 2014. My solution, JavaScript. So I would then use JavaScript to calculate document.innerHeight. And this is the height minus the Chrome. And then I would set the height of the element to a discrete pixel value based on that on page load. It was pretty lame because the page would load, and then after the JavaScript executes, you see a little jump in size, but it was the best we could do. Today, with dynamic viewport units, this is no longer the case. So instead of just VH, we get SVH, LVH, and DVH. Let's look at them in some depth. SVH is for small viewport height. This is equivalent to the height of the viewport when all of the toolbars are in view, right? So it's what I would have wanted back when I started my career. LVH, so 1 LVH, is 1% of the viewport height when there's no toolbars obfuscating the view. So SVH, small viewport height, LVH, large or long, depending on who you trust, long viewport height. And it's just the full, it's what 100 VH was. Finally, there's DVH, which is dynamic viewport height. And this is cool because it's, when there's toolbars, it's 100 SVH. If it's like 100 DVH is 100 SVH. And if there are no toolbars, then it's LVH, and it just switches between them. One caveat here is it does not guarantee 60 frames per second buttery smoothness like when the toolbars appear and fade out. So you may experience some jank, but it takes a lot of the thinking out of it, and you can actually trust your units. This is really cool. This is also supported everywhere and in all major browsers, and is something we can leverage today. This has been the lay of the land for CSS, and it's honestly an exciting time because CSS level 4 it actually brings a lot more. It brings the is selector, it brings the where selector, it brings a number of things that we're not going to talk about, but these ones I found to be really ubiquitous. And in a number of events and conferences that I've talked to, I don't talk to events and conferences, and a number of events and conferences where I've spoken to many, many, many developers, these are the ones that keep coming up with people going like, what is that? Why does it matter? Why is it cool? Etc., etc. And so I thought it's relevant to just flag them for you here. One more question about CSS that I often get while we wrap this up is, why? Like, why are we adding all this stuff to CSS? Because as I mentioned earlier with the viewport height example, we can do this with JavaScript. Just like add some class names here, do some things there. A lot of the things that CSS is adding, especially around like the statefulness, is possible with JavaScript. So why then are we adding them to CSS? And I actually had the privilege of asking my dear friend Una Kravitz about this, who is the world expert on CSS, literally shares the latest information, is on the committees, etc., etc. And Una gave me a really great answer, right? Una said CSS is for presentation. It's for how your website, your web app should look. It's for the style of it. JavaScript is for the logic, is for the state, is for the interactivity. And separating these concerns serves us very, very well. So CSS and JavaScript, maybe they allow some overlap in terms of functionality, but their purposes could not be more distinct. And at the current point in time, maybe before CSS level 4, there's a number of things that CSS needed to be able to do for appropriate styling, things like container queries, view transitions, etc. You can do view transitions with JavaScript. In fact, AngularJS did a long time ago. But the question is, should you? Should you use a language for interactivity, statefulness? Should you use that for styling and aesthetics? And philosophically, the answer is categorically no. And that's why we're getting these things in CSS to help us do our best work within the domain of aesthetics and styles. And JavaScript does what JavaScript does. So separating these and giving you the right heuristics for your given tool inside your given domain is the key. And to that end, I think CSS is on a really great way and doing a really great job. Okay, let's talk about what's new in JavaScript. JavaScript has a number of new things, and these are the ones that keep coming back from conferences or tech events or people I talk to. So let's go through them now in fun rabbit hole format. I hope you're enjoying this. By the way, if you're enjoying this, feel free to leave us some comments or reviews where you're at. That'd be great. Okay, so what's new in JavaScript? We have Object.groupBy now. This is so cool. Why is Object.groupBy so cool? Because it removes some of our dependency on Lodash. Now, no disrespect to Lodash. Lodash is super great. It's very useful. However, if we're not careful, it can add an enormous amount of bloat to our bundles. Oftentimes, we intend to import like one function from Lodash and tree shake, meaning remove all the stuff we don't use, but we accidentally include all of Lodash, which is orders of megabytes into our application. And then our applications contain way too much JavaScript, and they become too slow, and then our users complain because it's too slow, etc., etc. So Object.groupBy reduces one use case of Lodash, which you used to do like Lodash, aka _.groupby. Now you can use Object.groupby. And how it works is like this. You pass in an array of objects as the first argument, and the second argument is an accessor function that gets a single object from your array as an argument. And then what you can do is you return the anticipated keys of your new grouped by object. So assuming an array of objects with name and age properties, you can then say for the second argument, you destructure the age property, so you get the age property, and you can say if age is less than 21, then you return less than 21 as a string or a number. You can't do that as a number, as a string. And else you return greater than 21 as a string. And then what you'll get is an object grouped by age. So you'll get an object with two keys. The less than 21 key will return objects, an array of objects of age less than 21, and the other way around. So it's just a really cool way of grouping data, and it's native to JavaScript now. And it's supported, as far as I know, everywhere. So this is super useful. It removes one dependency on Lodash and helps us ship a smaller, lighter, faster web because we've offloaded this to the runtime. The runtime being the browser and Node.js, which is so very cool. So awesome Object.groupBy. Number two, we've got a bunch of new array methods. And this is also really, really cool. I really enjoy this. Specifically, we have array.toSorted, .toSpliced, and .toReversed. And you may be thinking, wait a second, don't we have array.sort? What gives? Why do we need array.toSorted? What's going on? Or toSpliced? Don't we have array.splice? Don't we have array.reverse? Yes. However, these ones prefixed with to, so toSorted, toSpliced, toReversed, the cool thing about them is they do not change the original array. They are immutable variants of the former mutable functions. So array.sort, given an input array of reference A, meaning you have an array named A and you give it to array.sort, or you just do a.sort, what's going to happen is A itself will be mutated. And so this is dangerous for some reasons. For example, if you export that A, or if you use it somewhere else in your long application and change it there, you may forget that it's changed, but it is changed. It's a different array. And then if you access like index 2 of this thing somewhere expecting the original unsorted array, you're going to have a problem, right? Array.toSorted for a given input array of A returns you a sorted array B. So it gives you a new array, a new memory reference. So your original array is safe, gives you a new one. This fully embraces immutable programming patterns and enables safer code that way. And so what I can hear at this point is a number of like functional programmer aficionados go like, yeah, that's awesome, great. Functional programming should be the only way. The only way is functional programming. If there's no functional programming, you're a total noob. And I think let's maybe not go that far. Functional programming is great. I love functional programming. Why do I love functional programming? It helps thinking in isolated, discrete units of work. That's really cool. It helps thinking in terms of inputs and outputs. And state is not long-lived, meaning a function typically takes an input, gives you an output, and that's it. In functional programming, it's pure. It does not touch anything else. It does not call out to the network or console. It just does a job. And so for my mental model, this is great. What's the alternative is classes, right? You create an instance of a class. The instance lives long. Its state changes, sort of like you as a human being, right? You're an instance of a class human, and your state changes over time. You live long. I find that harder to reason about than functional programming because state that changes over time becomes hard to predict and also hard to account for. For example, I'm a human being in my 31 years. Believe me, my state has changed. My state is changing right now. My mouth is getting drier because I've been talking for so long. My state is changing to hungry and thirsty. And then after this, I'll drink something. My state will change. You get the idea. So in an environment of volatile state change, predicting and using that state becomes challenging. And functional programming says, cool, I don't care about your state. I just do a job. So my function drink is I take a glass, I swallow its contents, cool, I'm done. It doesn't care if I'm thirsty or hungry. It's just event-based, right? And so for me, this is easier to reason about. However, functional programming is sort of safer in that way, but it is the slower of the two. So there's trade-offs. Why is it slower? Because immutability requires more memory, for one thing. So it just uses more memory because you don't just have one array. You have A and you have a copy B that you've mutated and recreated. So you have more memory consumption, but you also have like more memory utilization in copying stuff. Because if you have like a 10,000 element array where a mutable approach, so mutating the array in place, would just go in and surgically change some things in this array. An immutable approach would first have to copy each element into a new array and then operate on it. So, just by virtue of that, immutable programming, often coupled with functional programming, is slower, right? And so it's not always better. It just depends. Thankfully, today we have machines that are more than capable of dealing with those workloads, and so we're fine. But oftentimes, mutable code is faster code. However, once again, it comes with all of the problems of mutable state. For example, you may inadvertently change something during the lifecycle of your app, and you may not know. It may be impure. What does impure mean? You may have functions that sort of capture scope outside of themselves, and you may depend on things, and you might end up with spaghetti because your scopes are just, they don't matter as much anymore. And so your code becomes somewhat entangled with mutable code. And immutable code helps encapsulate things that you can then go on and unit test and so on and so forth. Anyway, without digressing too much, we now have immutable array methods that help with this. Okay, so again, keep in mind they are slower, but they are safer. So pick your poison. And this is the case with everything on the web, right? It's all trade-offs. It's just a matter of which trade-off you choose. All right. Next up is something that not a lot of people know about, but I think a lot of people should. It's worth mentioning at this point in time, I have absolutely no financial relationship with with the company I'm about to talk about, with either company I'm about to talk about, but NPM. We all use NPM. NPM install podcast. We all use NPM probably every day. If we don't use it directly every day, we use it on CI/CD. Somewhere NPM is being used every single day. The creators of NPM, Isaac, Darcy Clarke, these are the co-founders, literally invented NPM. NPM was then acquired by GitHub. And after it got acquired by GitHub, a number of things happened where it was clear that the way the inventors wanted to take NPM was not the way GitHub wanted to take NPM. And so, dang, that's tough. What happened is Darcy and Isaac left and started a new company called Volt. That's a VLT. You can go check it out today, vlt.sh. Once again, I don't have a financial relationship to these folks, but I think it's cool. And the vision for Volt is to reimagine what NPM would have been had GitHub not acquired it. And I'm not saying that to disparage GitHub or be controversial. That's just how it is. What could NPM be if it was fully built to the ideal vision of the founders? NPM has stagnated. It took a very long time just for the audit feature to come out. And really, frankly, not much new stuff has happened in NPM recently. More than that, people don't use the NPM client by default for the most part, right? Many of you, let me know in the comments if this is true or not, but I suspect many of you are using something like pnpm or yarn. pnpm probably because it's lighter and faster and frankly has like better heuristics around caching that make it more effective. I've actually run pnpm on airplanes without Wi-Fi and found out, oh, cool, I just have this in my cache. So yes, NPM either on the front end, on the back end, on the infra side has just stagnated. And VLT or Volt.sh is a reimagining of this that provides a number of new features that developers have wanted, that I have wanted for years. What are some of those features, you may be asking? Well, for example, I've used a package called Verdaccio, Verdaccio, Verdaccio. Some of you have used it, some of it maybe haven't, but here's the deal on Verdaccio. It's an NPM registry that you run locally. So npx Verdaccio will start an HTTP server locally on your local host, where you can then npm publish packages to it just to test that what you're building, shipping, and publishing is actually good, right? And so you npm publish to your thing, and if you run it on a local network, you can have your teammates, set up 192.168.1. something, so a local network IP address, and npm install from your registry just to make sure that thing installs and it works and so on. And then when you've tested it, you can actually publish to the NPM registry. Verdaccio, so cool. This isn't a native feature to NPM. I wish it is. Darcy tells me they're planning on adding this. Another basic feature I've hoped for NPM in a very long time is staging environments for packages. This would also solve the Verdaccio problem. So all of this is coming to Volt, vlt.sh, and I'm very excited about it, and I'd encourage you to keep your eye on it as well. Bun, an alternate runtime to JavaScript like Node.js, also is a thing people are talking about. It's equivalent in some ways to Node.js. It was advertised as a drop-in replacement to Node.js. It is not a drop-in replacement to Node.js, but it wants to be one. And so maybe it'll get there one day. Bun is a JavaScript runtime that is an environment in which you can run JavaScript like a browser or like Node.js. However, it's written in a programming language called Zig. And Zig is just fast. I don't know why Zig is fast. I plan to do a podcast episode on Zig and do a deep dive on it and explain and learn myself why it's so fast. But yeah, Bun is that. But it's not just a runtime. It's not just one-to-one equivalent with Node.js. It also is a test runner. So it's like Node.js plus Vitest in one. It's if Node.js and Vitest had a baby. But it's not just a test runner and a runtime. It's also a package manager. Oh, cool. Okay, so it's like Node and NPM and Vitest had a baby. Indeed. But it's not just that. it's also an HTTP server. Okay, so it's like Node.js, Vitest, it's Node.js, Vitest, NPM, and Express had a baby. Indeed, it's all of those things. It aims to be like a tool chain for JavaScript developers. And also it has first-class TypeScript support. So it's just like everything. It's, I think, everything most developers want NPM to be, but NPM has stagnated, or Node has stagnated somewhat as well, because it's frankly large. And you know what? I'm part of the camp that doesn't disparage Node.js or the fact that it maybe moves slower than we want, and it doesn't include all of these extra bells and whistles, because guess what? It's massive, and it's used by the literal world, right? Like Netflix, Amazon, Google, like everyone you use daily probably has some Node.js services going on in there. So I think to say, oh, awesome, Bun's showing up and going to destroy Node.js is a bit premature, because it's a new thing. It's not used anywhere. Of course, it's going to be better because they have the privilege of no users. But just because they can move fast and break things doesn't necessarily mean that they're better. I'd love to see it better, maybe proven over time. But for now, it's a apples to pencils comparison, right? You can't compare old thing to new thing so easily. All right. Another thing that keeps coming up, and this is, I do have a financial relationship, not with this organization directly, but with one of their partners. So Tauri. For those of you who don't know Tauri, really exciting. Tauri is a way of building desktop applications where the front end is JavaScript and the back end is Rust. Very similar in spirit to Electron, where you build the front end and the back end in JavaScript with Electron, Node.js for the back end. Slight differences are around the back end piece and actually the front end piece. So let's contrast with Electron. In Electron, which is a way of building desktop apps with JavaScript, you build your application using React, Solid, whatever it may be. And on the back end, on the Node.js side, you can use Express, Koa, Happy, some HTTP server if you want. You can access the file system. I don't know what your application does, but the idea is it's JavaScript all the way down, okay? The only drawback here is it's very, very large. How large? I'd say like half a gigabyte or something for a Hello World app, 500 megabytes or so. Why is that? Well, because you ship Chromium for the front end. You literally ship a browser without like tabs and stuff for the front end. And you ship the Node.js runtime for the back end. And both of these are pretty heavy. They're hundreds of megabytes. And so Tauri says, what if it didn't need to be so big? And so Tauri prides itself on being very, very small, because it doesn't ship anything extra. So how then does it paint web pages? How can I build front ends with React or Solid or Qwik in Tauri? And the way it works is every operating system, Linux, Windows, macOS, has a built-in thing called a web view. And it's exactly what it sounds like. It's a window without a frame or anything, or rather with a frame, but without any like toolbars or anything, that render web content, HTML, CSS, JavaScript. This is baked in every OS. This is what browsers use under the hood, right? A web view. A browser is like a web view with extra controls, okay? So the OS gives you the web view. Tauri says, take the front end, put it in a web view. Cool, that's the front end piece. So it doesn't ship anything extra. For the back end, as in to access the file system, to do network requests, etc., that's all through Rust, literally. Like, and Rust is a systems language. It runs directly on the CPU. It's not, there's no JavaScript runtime, so to speak. It's a systems language. It's like C++. Okay, and so you get data from the Rust side to the Tauri side through something called IPC, or inter-process communication. In fact, I think Electron has IPC also, and so how it would work is you, in the Rust side, you read something from the file system, serialize it to text, and say, send to front end. Send it to front end, render it in whatever front end UI library you seem to like, React, Solid, Svelte, whatever. And so what we're doing here is we're shipping absolutely nothing extra besides the JavaScript bundle. And with an Electron app, you ship a browser, Node.js, and the JavaScript bundle. And so it's smaller, but it's also safer to some degree, because in Node.js is just not secure. Like if you npm install and then npx something I tell you to, I have access to your file system. I can just delete the contents of the directory where you call like my npx thing. Node.js doesn't ask you for permission for things. It doesn't ask you for, hey, can I read the contents of this folder? Hey, can I delete this? Hey, can I? It doesn't have that security layer. Tauri does, because it sort of has security baked in as a first-class citizen. And honestly, I know the Tauri folks, they care a lot about security. Like, they have a team that audits each release as well to make sure that nothing nefarious is happening. So Tauri, smaller, safer way to build desktop applications with JavaScript. However, the only stipulation is you also need to learn Rust, and you need to know Rust to do backend stuff. But is the trade-off worth it? I genuinely don't know. This depends on your use case, and it depends on whether you feel like the size matters that much or not. I did mention 500 megabytes or so for Hello World Electron app. I think it's within the tens in the case of Tauri. But I've also seen people make like system tray applications, so just like a little icon near your clock, and those are, I'd say, under even 10 megabytes. So very, very cool. Finally, in the JavaScript side of the world, I think we'd be remiss if we didn't talk about frameworks and UI libraries. But you know what's really cool? There's almost nothing like that new in the framework world. Qwik version 2.0 is coming out. We'll talk about Qwik in a second. But I think what we can say definitively in the front-end world is everyone except React has adopted signals as a reactivity primitive. And that is pretty huge. That is a big deal. Signals as a reactivity primitive started with like Knockout.js many years ago. However, it was never popular because its developer experience didn't have comfortable heuristics. It wasn't so approachable to use, right? And so since then, since 2013, React has been top dog. And React, if we speak frankly about it, it's just functions calling functions. So you have your page, which is a function. Inside it, you have a sidebar, which is a function. Inside your sidebar, you have a button, which these are 3 layers of functions. And so when something changes on your page, maybe the navigation path changes, the page function is called, then inside it, all of its children are recursively called. So the sidebar is called again, the button is called again. Even if the sidebar and button did not change, unless you memoize them using React.memo, they will be called again. This is how React works. Okay, when a state update happens, all of the children that are not memoized will be updated unless they are exclusively memoized. Okay, this again how React works. Eventually, Ryan Carniato, the author of Solid.js, shows up and says, "Cool. This is great, but I think we can do faster. We don't need all of this recursive function calling when state doesn't change. What if we could have the reactivity be more fine-grained? Meaning, if I update a thing in my app, only that thing changes. Its children do not change. Just the thing changes. In fact, not just the thing, everything that is reactive, only the reactive piece changes." And the way he did this was by hearkening back to Knockout.js all those years ago, looking at the observability or the observer pattern and giving it a revamped developer experience. So you might be asking, okay, what developer experience did he give it? And he gave it JSX. So the code of Solid.js looks exactly the same as React. The only difference is instead of use state, you have create signal. And when you read state, you don't reference some identifier, like some variable name, but you call it as a function. So it's always a getter, right? But all Solid.js function components never re-render, meaning the functions are never called, ever. It's just where state is read, their state is updated. So functions are never called. And indeed, Solid is measurably faster in product code than React. Why? Because React application code, and I'm not saying framework, I'm not saying library code is slower, but application code in React is often slower than Solid because as React developers, we just sometimes forget to use memo or to memoize components. We don't think about that. And maybe we should, right? Maybe the qualification and definition for a React engineer should be you don't just put buttons on a screen and then add on click, but you also consider memoization, you consider lazy loading, you consider accessibility, you consider load. Maybe that's part of the description, but for whatever reason, the vast majority of us working in React don't go for memoization out of the box. And there may be an argument to be made that we perhaps shouldn't. If React is supposed to be a declarative abstraction where we just describe our user experience or user interface and then React does the rest, why should we think about memo? Is this not leaking implementation details, right? And so that's where we are. Everything, Svelte, Solid, Qwik, Astro, Angular, has adopted, signals. React has not. And this is really interesting. You might ask yourself why. What's going on? So I had the privilege of talking to the React team. In fact, I might interview some of them. And the answer is so cool. The answer from the React team is this. We don't think signals should be exposed. Signals are an implementation detail. And so they work great, but React, and this is according to the React core team, has always been about ideal developer experience with declarative code. What that means is you declare what you want your UI to look like with JSX. You declare how you want it to change with on-click handlers and hooks. And then React does the rest. It reconciles virtual DOM with real DOM, and everything just follows. And so to say, now you have to think about signals and so on, it's leaking implementation details. However, with telling us to use memo and memoize components so that React can then be performant, that's also leaking implementation details. So the solution, according to the React team, is somewhere in the middle. It's not explicitly, let's go use signals, but the React team is working on an automatically memoizing compiler. What that means is when you npm run build, it will automatically inspect your code. It will literally read your code and go okay, cool, that variable is not going to change. Let's memoize it. Okay, cool, this component is never going to update. Let's memoize it. And so intelligently we'll build a reactivity graph and go okay, this stuff's not going to change. Memoize it, cache it, this stuff, and so on. Ultimately giving you a highly optimized, fine-grained reactive user interface. React Forget. That's I believe it's already in use on Instagram and WhatsApp, and slowly they might roll it out. I do have concerns with this. I don't know, just my naive developer. I predict there may be bugs where a value is not updating. What do? I've fallen out of reactivity. This happens with Solid, and it may happen with React. I hope not, but I was told that the compiler works by using the rules of React as cues. And what are the rules of React? For example, a component can never mutate its props. So if you're doing that, you might, have issues. But the cool thing about this compiler also is it doubles as a linter. It can tell you where you're breaking the rules of React and help you write better applications. Still, the question that is burning here is this going to be as fast as or faster than signals, for reactivity? And the answer is no. I don't think so. And here's why. As we mentioned, React recursively calls functions. So if my button at level 12 of nesting changes, then actually let's change that. If the top level component changes, then everything underneath is called. Every function underneath is called, and updates happen where updates need to happen. However, if something is cached or memoized, the functions will still need to be called. They'll need to be called, and the compiler will return a memoized value. So computation will not happen, but the function will still be called and yield immediately. And so you still walk through a tree of virtual DOM. With signals, you never walk through a tree of anything. You just literally maybe you walk through a reactivity graph where one signal depends on another, but signal reactivity and UI structure are completely decoupled, right? And so you will never have the same level of nesting as your elements as your signals, unless you work really, really hard. And that's why I believe signals will be faster. But again, this is too preliminary and we don't know yet. So when Forget is out, we'll do a podcast episode, a deep dive on it. We'll talk about its ins, its outs, its heuristics. We might even do it with Satya as a guest from the React team to guide us through that. If you want to catch that, of course, feel free to subscribe. But that's where we are. Okay, finally, let's talk about Qwik. We did mention Qwik. Qwik, as we mentioned, has support for signals, except Qwik has a marked difference to everything else, and that's its first-class usage of lazy loading. So among all the front-end libraries around, Qwik is the only one that does not ship any JavaScript except its bare bones runtime to the browser. So Qwik always deterministically ships 1 and only 1 kilobyte of JavaScript to every website. This is why people sometimes call Qwik the O of 1 framework, because O of 1 meaning just one thing. It loads one predictable thing every time. Usually they say, you load n kilobytes, megabytes of JavaScript, depending on how much code you ship. It's variable. With Qwik, it's constant. It's constant because you just ship the Qwik runtime. Okay, but what if your application has JavaScript that you need to ship, for example, to respond to buttons and so on? Qwik replaces all your onclicks with lazy load imports to those onclicks, such that you don't ship any of your onclicks, really any JavaScript code by default, unless it's needed. And then a user goes to go click on a button that you've added an onclick to, and instead of executing your onclick, it will execute an asynchronous import of that module, download the JavaScript for it, and then invoke the function that it exports, all instantly. And so it only loads and executes the JavaScript that is needed when it's needed. And that's why Qwik is smaller and faster than any other tool for building UI on the web today. If nobody uses your website, you always ship 1 kilobyte of JavaScript. If somebody clicks on the button, then only then is that onclick imported, executed, and run. And so it's quite cool because we have to consider, right? Like in all of the websites and applications we build and ship today, like how many onclicks are we shipping that nobody ever clicks on? Right? How many on changes are we shipping where nobody types in an input field? With Qwik, the user only ever downloads the JavaScript that they actually use. And I think that is so cool. Now, make no mistake, Astro has support for this as well. However, with Astro, it's not automatic. You have to say load this when the client is ready, load this when the client has loaded. You can use these directives to control in a fine-grained way when you load JavaScript. And so you can get close to Qwik, but Qwik honestly just blows everything else out of the water with how simple it makes this and how predictably it works every time. One stipulation with Qwik that people often ask about is, okay, but what if I have no internet? What if I'm going through a train and I click a button and then it can't download the JavaScript? The cool thing is Qwik does download all the JavaScript ahead of time, just in a non-blocking way somewhere. So your website becomes interactive, everything's ready to go, and Qwik has all this prefetched. And so when you click, it will just get from prefetch cache. It will not get from the internet. And so that's really cool. The other thing is Qwik champions something called resumability. And resumability is somewhat different than hydration. Hydration meaning your website is server rendered and then sort of comes alive when the client-side JavaScript loads and executes. Qwik champions resumability where there is no hydration step. So let's walk through this a little bit. So for a server rendered website, you take your React solid, whatever it is, turn it into an HTML string, and then stream or send it to the client browser. And at that point, it's just static HTML. There's no JavaScript on the page. Then you download the client-side JavaScript bundle that contains exactly the same code to get to where you are. And slowly, that bundle gets an idea of what the DOM is and attaches event listeners and becomes interactive. Qwik never hydrates because nobody does any, like it only loads things when they need it. So it sends a string or stream of static HTML. Everything is serialized over the network, loads in the browser, and that's it. It's ready to go. Then when a user clicks on something, that's when the handler is downloaded and so on. So the cost of hydration is just not there in Qwik. Therefore, Qwik is still faster. Let's wrap up this section by talking about Astro. Astro pioneers something called islands architecture. So Astro is fully static. Astro is basically HTML with components. So with Astro, you write these .astro files, which are literally just HTML with some front matter. Front matter is if they accept props or something as components, you do dash 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 and you describe some JavaScript, and then you do dash 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 again, and that's the script portion of it. And then you just write classic HTML that you know. And then you can compose Astro files into Astro files, therefore they're components. But there's no primitives or interactivity out of the box other than like just standard HTML script tags. Now, if you wanted to use Solid, Qwik, Svelte, React, you could use any UI library with Astro. They have adapters for all of them. And so what you can do is you can have your entire site built with Astro components, but for one region or another region that you want to be responsive, interactive, with Solid, you just do a .tsx file with Solid code, and Astro will automatically splice the Solid components with your Astro components and just work. And I've used it. I've built multiple things with Astro. It literally does just work every single time. The team, Fred, K. Shot, Elian, have done an amazing job there. And honestly, if I was to build any website or web app with anything today, I would choose Astro. I wrote the book on React. I still choose Astro. It is just that good. Okay. Again, I have no financial relationship with Astro or Solid or React or anyone. Frankly, I do have a financial relationship with O'Reilly, where I wrote the React book, but all of this is just me talking about friends. Okay, cool. That's it for the section on JavaScript. I hope this has given you some interesting insights and further food for thought, but I think that's enough. Let's move to the final section of this episode and talk about HTML. I realize many of us are going, HTML? What? This is new stuff in HTML? Yes. HTML is great. There's always new stuff in HTML. I want to highlight 3 specific things. We will go into some detail, as we often do, but I'll try and keep it short because we're already getting quite into it. And gosh, there's just so much to geek out about. Okay, let's start by talking about OpenUI. What is OpenUI? OpenUI is an initiative by the W3C, essentially a hobby project by the W3C that aims to make traditional HTML elements more stylable. I think this is so cool. So for example, some elements like select, the dropdown, or input type checked, input type, sorry, not checked, type checkbox, input type radio, like form controls are notoriously difficult to style. You can use all unset, so just remove all the styling. Even so, in some cases, the user agent will fight you. I think of like the Microsoft Metro UI, right? Like in Windows 8, where select boxes were just flat and they had their own drop-down behavior, including animations and so on. To this day, in Mac OS, the drop-downs are system style. It's so weird. It's like we get our styles overridden and we can't fully customize these elements. OpenUI is the answer to that, and I'm so excited about it. So just like the select element in HTML, OpenUI has been working on an element called selectmenu, which intends to replace select at some point. Selectmenu is really cool, and it's just months and months, I think even years of iteration on, okay, how do we take a select element and all of its edge cases and to it add stylability but also accessibility on a standards level. It's so cool because if Jed Watson is listening, the author of React Select, or even Kent Dodds with Downshift, you'll know that there's a lot of things that go into making a select element useful and accessible and stylish. For example, what happens when you click on it and expand it? What happens to the area behind the elements? Does it affect layout? Does it not affect layout? Does it have a close button? Does it close when you click outside? Should it close with a prop when you click outside? What about screen readers? How do they read options? What about tab index? So all of this stuff and the aesthetic stylability of it is being addressed by OpenUI with selectmenu. Very, very cool. And I frankly have felt this pain so many times, and I'm so ready for selectmenu to come. Above and beyond that, OpenUI is creating a popover component as well for things like tooltips and popovers. So all of this falls under OpenUI to give us way more, once again, say it with me, control, to style things exactly how we want and to have them behave predictably across platforms. At this point in time, OpenUI is nothing more than an initiative, but I hope for a future where it becomes part of the W3C, part of the HTML living standard, frankly, where we have these components and we have a new web. I think HTML is due for an update anyway. Another new element, speaking of HTML, is the dialog element. This is so cool. I need to preface this by saying I'm not a fan of modal boxes. I think on the current state of the web, modal boxes are heavily overused. I've been part of teams where the product owners have asked for modals, and then eventually when things became clear, when requirements grew, needed more modals inside the modals, and then the twice nested modal had a save as button that then required another modal to open the file. So it just modals. In fact, modals oftentimes are cop-out. I said it, this is a hot take, are oftentimes a cop-out for less out-of-the-box UX thinking. For more out-of-the-box UX thinking and good practices, I'd recommend checking out my dear friend Vitaly Friedman's resources over at Smart Interface Design Patterns is his course, also smashingmagazine.com. I have no financial relationship to him. I do have a friendship relationship with him. And yes, you'll see why modals are maybe not the best choice initially. Now, that's not saying modals are always a bad choice. There are times where they are well and good. For example, confirmation when you're going to delete something. Modals are great for this because they literally block everything and ask you, are you sure, right? So it's not that they're bad, it's just that they're bad when they are like a quick thought instead of deeply thinking about how to solve UX problem. Anyway, we're not here to talk about my opinions with modals. There's a funny website, by the way, modals.com. That's MODALZ 3 times.com. Great satirical website about modals. That was my phone, excuse me. And so, okay, modals, what's the deal? The dialog element is an HTML element that makes modals easy. Not just modals, dialog. It literally puts a pop-up over your UI and manages z-index, stacking context. All of the accessibility and usability concerns are handled for you. The only thing left for you to do is to style it. You can even style its overlay. You can define behavior where if you click on its background, it closes. Beautiful. It also has JavaScript APIs that allow you to fully interact with it. That's the dialog element. And it's just great to see HTML and the web platform, including like with things like view transitions, as we've discussed and so on, recognize pain points that developers have to solve repeatedly and then solve them at a systemic standards level. I think this is so cool. So OpenUI with select menu and popover and the dialog element is something that I'm very, very excited about. New stuff to HTML. Okay, finally, let's wrap up by talking about HTMX. Very controversial these days. A lot of people saying it's good, a lot of people saying it's bad. I'm here to give you a balanced take on HTMX to really just eliminate any imposter syndrome you may have and give you a confident basis through which you can talk about HTMX. HTMX is really great in some cases where you just don't want to deal with like build tooling. You don't want Vite, you don't want Next.js, you don't want a framework, you just want, look, I just want HTML that works, that gives me fully dynamic web experience. It just works. And so how does it work? So HTML's whole thesis is asking the question, hey, why is it that only image, that is IMG tag, only image elements can do network requests asynchronously? Like for example, forms have actions, and when you submit a form, it takes you to a whole new page. When you click an anchor link, it takes you to a whole new page. But an image will do an asynchronous request over HTTP, a GET request, to the URL and retrieve the binary data, the image data, and then paint it. Why does image get special treatment? And why is it only the GET request? Right? Why can you only click on buttons and anchor links to like do stuff like navigation or bring up things? Why is it restricted? So HTMX says, you know what, let's extend hypertext to have these behaviors shared across all elements, and let's augment them through special attributes prefixed with HX dash. That's all HTMX is. It's a way to make everything in the browser interactive. So if you have a div and you do hx-post as an attribute, hx-post equals, in double quotes, some URL, then that div, when you click it, will make a post request to that. Cool. And then if you want to not have it work on click, but maybe on key press, maybe when it appears, instead of hx, not instead of, excuse me, then you would add to hx-post, you would add hx-trigger, and you can say click, you can say, I think up here, you can say a number, read the docs, but you can say when it makes the post request. And then finally, there's hx-swap. And you can say, okay, so after the post request finishes, take the server response and swap out either the children of the element or the element itself or the outer scope of the element. Or some CSS selector, go swap out the contents of some other element. You can do all of this with these attributes. So HTMX exposes a number of attributes that augment your hypertext to add rich behavior. How you get started with it is you add a script tag. That's so cool. There's no build system. There's no rollup. You just literally go script src unpackage.com/htmx or something to that effect, and you can start using these attributes. And the really cool thing is it supports a lot of various use cases. With HTMX alone, through the use of these HX attributes, you can subscribe to a WebSocket. The WebSocket can send you messages. You can respond to those messages. You can render its contents somewhere, and you can do full like real-time applications with HTMX. It's really cool. All of the extra use cases you could use. In fact, you could build a full production application using just that. Now, why is this valuable? You may be sitting here as a React, Angular, Vue, whatever developer and asking, okay, but like, do I need this? Why do I need this? This isn't so appealing to me. Cool. Maybe it's not for you. Maybe it's for the Golang, the Rust, the PHP engineer who's outputting HTML but doesn't actually know React and has no interest in learning these things and just wants to make a really great front-end application with just HTML and one extraneous script tag, right? The web ecosystem is huge, and it's all not just React or framework developers. And so HTMX unlocks front-end to a number of these folks by just allowing a few attributes to do a lot of heavy lifting. So HTMX, really exciting. I've used it and I love it. I think where HTMX can really benefit is some type of component model, right? Because part of the value of React, Svelte, Solid, Angular, whatever it may be, is your ability to break these things down into small components and then test those components in isolation and then compose them together to form bigger UIs. And like the component, people say React is great because it's fast and declarative. I think cool. Maybe it's definitely not fast, but it's declarative. But the component model, for me, that's the thing. It's genius and revolutionary. So I think HTMX would benefit from this. I did speak with HTMX, and they mentioned that this is never going to happen because HTMX is all about embracing hypertext and the web platform. And the web platform has an answer to a component model. It's called web components. And so I was told, just go use those and augment them with HX attributes and they'll work. So no, fair. I think that's entirely reasonable. My mind is conditioned for React and these types of web front-end ways of thinking. So the other thing that I think HTMX would benefit from is some type of framework, like Next.js is to React, like SvelteKit is to Svelte, like SolidStart is to Solid, like Angular is, period, right? I spoke with HTMX. This is also not going to happen because this is still, it's HTTP, it's hypertext and then extra. And they don't believe that the benefits of a opinionated framework would help. And here I disagree. I disagree because it like HTMX exposes a number of things that are non-predictable. Like, for example, you can have a title element anywhere in the page, in an HTMX page, and the innermost title element will be hoisted and be the definitive title of the document, right? So for example, if you want to do if you want to change the page title in some type of soft navigation, you have a title up in your static HTML, and then through network request, you receive another title element. Oh yes, by the way, network responses in HTMX are HTML, not JSON, not XML. You literally respond with HTML fragments, and those fragments are embedded into your DOM. Anyway, so you could return a title element, and that title becomes the page title. It would help if a framework regulates that. Also, they invented an HTTP status code. And so this is, I mean, for me, this is definitely something that needs a framework because it's non-standard. When you're subscribed to a WebSocket in HTMX and you want it to stop, you want it to close the connection, you send a 286 status code, 286. That's non-standard, but 286 something in the food industry means to cancel it. And so 286 to cancel. Cool, but it would be cool if there was a framework that does that. So you call a stop function and it does that behind the scenes because it's non-standard. Why are you teaching people these things if it's non-standard, But again, HTMX doesn't want it. Doesn't mean it doesn't have to exist. If some open source developer somewhere feels as strong as I do, or stronger, probably they'll make it. But these are just two ways I think HTMX could improve. Just my opinion. Doesn't really matter, conjecture, but hopefully I've given you enough context there to have your own opinions and your own discussions. Once again, HTMX, great. You include a script tag, you get extra attributes to make any element capable of doing network requests, any element capable of responding to events, click or other, and any element able to update itself, to augment its inner content, outer content, or some other selector's content. Really, really cool. All right, this has been fun. Whew. As usual, we covered a huge amount of topics and we went pretty deep. We started with AI. It was 30 minutes on AI alone. And then we went to CSS, where we talked about view transitions. We talked about the has selector. We talked about container queries. We talked about a number of things. We moved to JavaScript. We went down the rabbit hole of immutability and Object.groupBy and why Lodash is bad. We talked about frameworks. We talked about Tauri, Volt, Bun. We talked about OpenUI and HTML and HTMX and all these things. I want to say thank you so much for listening and being on this journey with me. If you're learning from and or enjoying this content, I'd invite you to leave a comment, to like this on YouTube if you're watching, and then subscribe to it. If you're joining us on Apple Podcasts or Spotify, I would invite you to submit up to a 5-star review. It would be really awesome. Also, leave comments for episodes you want to hear about. I'm happy to cover them, and any criticisms or any feedback you have. I actually read all the comments and I make it a point to, because look, I'm doing this for you. And so I want to do it for you as best as I can. Once again, I want to offer this to you at zero cost, and I can only do that with sponsors. So if you're interested, or if you know someone interested in sponsoring the podcast, please reach out at Tejas Kumar on X. That's TEJASKUMAR _ at Tejas Kumar _ on X. And I'm happy to entertain any requests there. My whole mission here is to make this information free and available to you so that you can thrive and do your best work with the most confidence and have the highest quality conversations. Okay. Thank you again for watching or listening. Thank you for joining me, and thank you for your interest in engineering.